Hello everyone, today we're going to be talking about BIM assignment number 8, your second to last BIM assignment. Pretty exciting, right? This one is about sustainability and also site work. We spent all this time creating the indoors, which I like and we should all be enjoying right now, and now we will model the outdoors, the forbidden place that we cannot go. So this one is a little bit unique. Download 2 given files, and we're going to start with the site file. So we have BIM assignment 8, site given. Download that and open it up. Let's see what we're working with here. So I see a green box with a green rectangle in it, and then let's see an elevation view. I have two levels. If I zoom in really close, I see sea level at 0, 0, and then I see street level urbana at 100 feet. So keep that in mind. If you look at the deliverable and read this document very carefully, we have street level over here, and our building is to be located in urbana. So street level has to start at 100 feet. Alright, so let's talk about how do we actually model this surface over here. In Revit, that's something called a topo surface, topo for topography. So that tells you exactly how tall individual points are. These are the things that civil engineers, like what people call civil engineers in the industry, they do civil surveying, and they will actually be shooting different elevations. When you see people with those really weird looking camera type things on a stick that's yellow, that's actually a total station for shooting elevations. So the way we actually create those is under the massing and site tab, as you would expect in Revit. So in our site model, make sure that we have the correct model here. I'm going to start by creating a topo surface. So click on topo surface, and it gives me the ability to have an elevation. So every point that I place, if I notice here my cursor has become this little point thing, that's actually an elevation. Is there anything here that's at sea level? No. So we're starting at 100 if I read the instructions. Minimal elevation of 10, it needs to look something like this in the end. Baseline, my elevation needs to be 100 to be at the street level of urbana. So I'm going to first define the corners of my box. I've given you these green rectangles as reference points. So I can click 1, 2, no surface is appearing, no line is connecting these. Why is that? Well, a topo surface is a plane, so it takes 3 points to define a plane, 4 points to define our nice square. What else is there? Well, I know my building is actually on a little bit of a hill, just to give it kind of that grand stature. So around my building, I need to make sure that that's 100 plus 10. Do a little math. 110. So I will define these corners. And notice how my topo surface changes. Now, if I look at this in 3D, if I were to finish my surface now and look at it, it's become a nice little brown rectangle that actually slopes upward very slightly, but it is a 3D shape nonetheless. To give it a little bit more substance and character, I'm going to modify it a little bit. So I can just click on it and click Edit Surface. And then I can place more points. So I'm going to place more points and just place them willy-nilly around just to give it something, just a little more spice, right? I want to make sure that it looks more natural. Notice I have some areas down here that's for the parking lot, that's got to be at street level, so I need to actually define those points. So I'm going to just give that an elevation of 100 and just randomly place points around here just to make sure that there is enough space for my parking lot. I can even get some space over here. So that's essentially how you do everything with a topo surface. In real life, you'll be given actual elevations, and you'll have like target elevations. Here, do whatever you want, make it whatever shape you want. You can even see over here that we made like some water features, stuff like that. That's up to you. So that's how you basically create the shape of the outline. Just make sure that around your building it's exactly 10 feet higher than street level. So I'm gonna hit finish. And now in 3D, I can see my nice brown square. Okay, what's next? Well, we are actually going to be using the sub-region tool to define things. But first, before we get to that, let's actually make a building pad. So a building pad is the ground that we actually are setting the building into. And that's another part of that green reference rectangle that I gave you. I can't see it from here, which is a little bit annoying. But if I go to the street level of urbana, now I can, right? So what do the instructions tell me? Instructions tell me that I need to create a 197 foot by 82 foot building pad with a depth of 14 feet. You'll remember that 14 feet is the depth below ground of my building. So I'll create the building pad. And then I can use these reference points that I have very handily. I think I can pick lines, yeah. I can just pick lines around here. And the height offset, I want that to be minus 14 feet. So if I click on these lines, click finish, I now have a building pad in my object. Don't believe me? Check it out. This makes sure that you have the right size hole to put your building into. Okay, other things. We have to furnish our site. We have to dress it up a little bit. I don't like brown, so we're actually going to use the subregion tool. So the subregion tool allows us to split up our surface into different materials. And changing the materials is the exact same way as you change a material in regular Revit, so I'm not going to waste a lot of time showing you how that works. Instead, on my site plan, all I have to do is define a subregion. And defining a subregion is literally just drawing. If I'm going to draw this street, for example, I will first just draw some kind of reference line over here, just splitting it up. And then I can just close it off. How wide is a street? Typically about 20 feet. So I can then define a subregion over here. Hit escape to exit the drawing tool, hit finish. Now I have another region within my topo surface that I can define its material to be something. If I click on this, it will bring up my material browser. And then I can find what I want. What are roads typically made out of? Well, you can either have, paved concrete or paved asphalt. Here, you can use any of these asphalt materials. You can create your own material. That's up to you. Right now, just for simplicity, I'm going to change it to parking lot asphalt. And in our 3D view, you can kind of see how that divides the region. So that is how you, really quickly, divide subregions. You are going to have to make your own parking lot. You're going to have to define your own street. Within the parking lot, you're going to need parking spots. And parking spots are all site components. So site components, same as regular components. I can just click here. And by default, I have all of these lovely trees. You can put Japanese maple, Kosa dogwood, large-tooth aspen. It's up to you. You can place whatever trees you want. But there are also some other things here. You can have like parking components, right? Parking components, parking spaces. We can have different angles of parking spaces. Whichever you prefer, you have complete artistic license over this. You can even find some interesting things on Revit City and put them on the site however you like. So furnish it with trees, furnish it with whatever you want, and basically dress up your site to make it look good. That's all I'm going to show you on the site. The next thing I'm going to show you is how you actually do the linking component. So once you are finished with your site and do everything on your site first, save that file as a different name and save it somewhere where you're going to be able to find it later. So I'm going to save as a project, and I'm just going to save this in a location that I'm going to be able to find it. So I'll just save it in the same folder which I've put on my desktop. I'll just call it BIMA8 site complete, and then, I don't know, my net ID or something. Put it in here. All right. Now we're done with this one for now. What we're asked to do is actually do a link. So we're actually asked to link two files together. And a lot of you guys asked about this with regard to the design project. Having multiple people work on different parts and then linking it together is a pretty good idea. So this is one way where you're going to be able to make sure that you can work on different elements. And linking is super useful for either working on different parts of a building, like structural versus architectural versus mechanical, electrical, plumbing, fire protection, etc., as well as useful for multi-building developments, as so often seen today. So we can close out of our site view once we're done. Just close out of these views. And we can open up the other given. So I'm going to open and then I'm brought to this browser. Sorry, it keeps popping up on my other monitor. And then I will say BIM assignment 8 given building. And this is the building that we all know and love. If you'd like, you can also use your previous building assignment building. It doesn't make a difference, you can still use it. And here we go. So we have our typical thing. How do we create a link? Well, I'm going to go down in the project browser to Revit links. And if I click on Revit links and right click and then say new link, I can actually link two models together. What does that look like? Well, I'm actually going to use my fully furnished site solution that I've already been through the effort of making. It's going to quickly upgrade that to 2020. Let us check if that linked properly. Here we go. So I have a site, I have a building. The building is not quite in the site that I want it to be, right? I want this to be in here, and I've got to get it into there somehow. How do I do it? Well, I'm going to use align tools, right? So let's see, is it aligned anywhere? Not really. Right now my building is under the ground. How do I make sure it's at the correct location? Let's see. So if I go to elevations, just pick any of them, I can see two things. I can see the street level of Urbana is at 100 feet, I can see sea level, and then I also see the elevations of my actual project. So it's actually brought these in. But if I wanted to change one of the elevations here, I can't. A linked Revit model will not allow you to make changes to the one that is linked. You can only modify the host model. That being said, we can still do some aligning, right? I want to make sure that these are lining up with each other. I want to make sure that my building is aligned with my surface. I know that my building is going to start at 10 feet above street level Urbana. What does that mean? Well, we're going to actually have to align it, and there are a bunch of ways to do it. I'm going to use a reference plane. So if I use a reference plane and I pick lines with a 10-foot offset, I can use this to create a reference plane here. Then I can use the align tool. What's the shortcut for align? I think it's AL. So you can then bring level 1, the starting level, up to that reference plane. So if I click where I want it to go, what I want to go there, I have a feeling I did this in the wrong order. Let's see what happens. Oops. So if you do it in the wrong order, it's actually going to bring the floor to the thing. Instead, we want to bring the thing to the floor. So I'm going to do it the other way. You first click on level 1, then you click over here. Oops, that's bringing the reference plane. Let's try this. Bring this to here. Oops, that did the same thing. Cancel. Okay, we're going to do this a different way. We're going to actually create the reference plane below my existing level. Because the thing is, the problem that happened there was actually I put the reference plane on the non-host level, the linked level. I want to put my reference plane based off of this. So I will instead create a reference plane, RP, and then I can define a 10-foot offset from level 1 downward. Then I can bring my street level down to that level. So first, using the align tool, type AL on the keyboard, I can bring this one down to here. So first I click on the thing I want, I think, and then this one. There we go. How about that? Okay, sorry. Now we can go back to the site plan and start to think about how do we move this to the correct location. So now I'm at the correct height, but orientation-wise, I'm not really there yet, right? If I go to, for example, the level 1 plan, I can actually see the back wall and then the hole that I want it to be in. It would be a perfect fit. It would be so good. I just need to align it. So we're going to use the align tool, AL. And then I can click on the very edge of my slab, and then click on this to align. Similarly, I can get the very edge of the slab on the front and bring it here. It is a perfect fit, as expected. So you want to make sure that your building is not buried under the ground, and that it's coming up at just the right level. So now we have it at the right level. It's possible to enter the building. We're not going to cause anyone to suffer. What's our last step? I mean, besides the energy analysis, which I won't go through. We have to rotate true north. And there's a super nice rotate true north video, if you ever forget how to do this. But this is something that's actually pretty important. So, right now, I go to my site plan, and I see this weird blue thing. It's actually two symbols overlaying each other. One is a directional marker, a project base point. This changes the orientation of the actual project. If I move that, the whole thing moves. This one is a survey point, which is internal, and I can just move this around. For clarity, I can just get it out of the way. So, here is the project base point. I want to make sure that this entire site, this thing is not like a diamond, rather it's like a square. That way it'll fit most efficiently into my sheet, right, for the site plan. So I actually need to change some things about my view. Right now, if I don't have anything selected, in my Properties tab, I see Orientation, Project North. If I change this to True North, nothing changes. And that's because right now, these two things are the same thing. However, I can modify True North. So if I click on this thing, and then in the Manage tab, I can change, under this tab, Rotating True North. I thought I was. 1 second. I am in a plan view. Site. Rotate True North. Views must be oriented to True North. Oh, modify the properties. Okay, first, I will create an annotation. That's another compass. So under annotate, symbol, I'm going to load in a family, and under the annotations folder in US Imperial, I'm going to grab north arrow. So I can either use north arrow 1, which is like this one. I prefer north arrow 2. It just looks a little cleaner. And I can just place it somewhere in my project. So here is a north arrow. Right now this is oriented to the project's orientation. But if I wanted to rotate this properly, I need to change this. I need to change the orientation to True North. If I hit apply, now is when I can start to change this. So if I go to Manage, Rotate True North, I think it's going to allow me to do it now. Here we go. How many degrees do I need to rotate it? Well, I've given it to you in this drawing. I need to rotate it 37 degrees. So I'm going to start vertical, right? Some kind of vertical reference point. And I want to rotate it 37 degrees such that the edges are parallel. Now, this is a little rotated, right? It's rotated to the correct direction, at least it should be. Then, I can just go to Annotate and place another compass on it, just this north arrow 2. I can just place it, and then I can annotate exactly how much that is changed with an angular annotation, right? So I can just measure the angle from this line, oops, angular, annotate, angular, from here to here. Oops, I grabbed the wrong line. Angular. Just pick any of these. All right. So beyond that, you had to do energy analysis. This is a super detailed guide, so just read all of this stuff very carefully. Some background on a little bit. This is a 12/6 facility. That means it operates 12 hours a day, 6 days a week. Central VAV, central variable air volumes. That's a type of HVAC system that's really common in commercial buildings. It has a bunch of other properties that you can configure. If you're interested in environmental engineering, this is really cool. Revit is actually a very powerful tool for you to analyze the buildings that you've created, so this is super helpful in design considerations. If you have any questions, feel free to post in the Discord. If you haven't set everything up yet, go ahead and do it. It is super simple, easy to do. That's all for now. Thanks for watching. If you have any questions, let me know. Good luck.